Dear guests, dear audience online and offline, good morning. Welcome to the parallel session 4, Low Carbon Energy Access for Rural Revitalization. It is organized by Rural Energy and Environment Agency, Ministry of Agriculture and Rural Affairs. We'd like to thank all parties for your support. Because of the pandemic, our speakers cannot come here in person, so we have a sub-session in Beijing. And now I'd like to invite the Chief Agronomist, Rural Energy and Environment Agency, MARA, Li Huibing, to moderate this session. Distinguished leaders, experts, and guests, good morning. Asia Pacific Low Carbon Forum. Parallel Session 4, Low Carbon Energy Access for Rural Revitalization now starts. Climate change is a global environmental issue related to human survival and development. This is an important challenge facing all countries. Responding to climate change is an inherent requirement of our sustainable development and our responsibility. To promote carbon peak and neutrality is proposed by Comrade Xi Jinping at the height of sustainable development of the Chinese nation and to build a community with a shared future for mankind. At the Central Rural Conference last year, General Secretary Xi Jinping pointed out that we need to achieve carbon peak by 2030 and carbon neutrality by 2060. To realize the carbon emission and carbon sequestration, it is an important measure as well as important potential. So this is a very important measure for carbon reduction by clean renewable energy. It is also important for building a pleasant living environment. We are calling for very vivid examples and practices. Today we have invited policymakers, researchers, and entrepreneurs to share successful experiences from both home and abroad to jointly explore the solution for the rural revitalization and carbon peak and carbon neutrality target. Here on behalf of MARA, here we'd like to thank Hunan government and ADB for holding this forum. I would like to thank you for your hard work. I'd like to welcome all the guests and representatives participating in this session. Here in Beijing, we are at China Agriculture Society, providing us with a very good meeting room. And Director Moore and the other leaders are participating in this meeting. But because of the pandemic, we cannot come to Changsha in person. Well, this forum is composed of two parts. The first is keynote speech. The second is panel discussion. So first, we'll start the keynote speech. It is our great honor to invite 6 guests engaging in the research of rural energy development. They are Researcher, Rural Energy and Environment Agency, MARA, Mr. Wang Jiuchen, Independent Consultant, Dr. David Van Hippel, General Manager, Beijing Borui Environment Engineering, Mr. Fang Fang, Senior Energy Specialist, ADV, Mr. Atsumasa Sakai, Deputy Director, China Architecture Design and Research Group, Urban Planning Group, Mr. Wang Mingtian, President, Senior Engineer, Nanjing Guochen DC Power Distribution Technology, Mr. Chen Wenbo. So first, let's welcome our first speaker, Researcher, Rural Energy and Environment Agency, MARA, Mr. Wang Jiuchen. His topic is Zero Carbon Village Concept and Rural Revitalization. Mr. Wang Jiuchen has been working in the rural resource development, and he used to be Director of Energy Ecology Division, Science and Education Department, MARA, Chief of Agroecology and Resource Protection Station. He organized the policy formulation, technology pilot work of the rural renewable energy and the rural resource and environment policies, making great contribution to the development. Now let's welcome Mr. Wang Jiuchen. Distinguished Chairman, distinguished guests, it is my great honor to participate in today's session. According to the agenda, I'd like to talk about the concept of zero carbon village and its relationship with rural revitalization. Talking about zero carbon village, first, I'd like to review the rural energy development history. Well, the rural energy development in China has been gone through a very long history. In the past 40 years, from the 1980s, it's been a very important historical stage. In the past 40 years, the rural energy development in China has gone through 4 important stages. The first decade was from the 1980s to 1990s. In that decade, we have done the national firewood stove reform and upgrade work. And we have done the upgrade and renovation of a large volume of firewood stoves. With the development of society and economy, from 1990s to 2000, it was the second stage. We did the rural energy comprehensive development with counties as a development unit. We have a 16-character policy for innovation. Entering into the new century in the first decade, we were conducting the rural energy comprehensive development based on villages. We did eco-residential areas and a demonstration villages plan. With further development, after 2010, the rural energy development started the development led by enterprises. We organized large-scale methane transformation and biogas project. Well, in the past 40 years, but every 10 years, we stepped up a new stage. The reason for this development was because we always follow the needs of the times to promote the development of rural energy construction. After 40 years of development, the rural energy development in China has made great achievement, mainly in the following areas. The first is we've made the world's largest clean stove industry. The second is we've made the world's largest solar thermal utilization industry. The third is we have built world's largest methane and biogas industry. The fourth is we have built world's most successful PV poverty alleviation model. Well, it makes great contribution to alleviate people from poverty. And then we've built the world's largest rural energy industry service team. So from central to rural places, we have formed a very professional team. So this is a review of the past 40 years. And now we have entered into a new development era. We are facing new situations and new opportunities and challenges with a new background. What should we do? We need further consideration and research. With this background, we need to face the requirement of the carbon peak and the neutrality target, as well as rural revitalization. In this new era, the main strategic tasks in China are in the following 4 areas. The first is to serve and support the carbon peak and the neutrality targets in rural and agricultural industry. right now we have reached a consensus for the carbon peak and carbon neutrality. Well, energy saving and emission reduction in the rural area is very important to realize this target. So this is our priority. There are two things to be done. There are two pathways. The first is to accelerate the low carbon and zero carbon villages development. So this is my main topic today. The second is regarding agriculture. We need to accelerate the development of climate smart agriculture for carbon sequestration, emission reduction, to stabilize grain production and increase income. The next part is to serve and promote the rural ecological revitalization. Well, in rural revitalization, a very important task is ecological development, including many areas. It covers a very broad content, including the life of the villages, including developing a pleasant living environment, including building energy efficiency, living a clean household energy, environment improvement, including kitchen and toilet revolution. The second is in agricultural production, we need green and circular development, including resource utilization of agricultural waste, ecological farm creation. There are a lot to be done. This is the second strategic task for the rural ecological revitalization. The third is to serve and promote rural industrial revitalization. We need to develop the rural industries. Well, in this process, we feel that the rural sustainable energy industry is an important component. So the third strategic task is to cultivate sustainable rural energy industries suitable for realizing the target of carbon peak and the carbon neutrality and a rural ecological revitalization. And then we need to explore rural energy development pathway with Chinese characteristics of low carbon, zero carbon, and even negative carbon. So in the new era, the rural energy development in China, we have these aforementioned strategic tasks. To realize these strategic tasks, we have divided our tasks into two steps. The first is with the backdrop of carbon peak, we are conducting low carbon village development. That is establishment of low carbon villages. Mainly in rural area, we need to promote low carbon and emission reduction technologies in the following 5 areas. The first is efficient utilization of agri waste. There are two main wastes. The first is straw for energy production, and then manure biogasification treatment. So this is a high quality utilization of the agri waste. Well, Chinese government is promoting the energy utilization of straw. We've invested a lot for this kind of work. Well, for the energy utilization of straw, we need to further enhance the utilization of the straw as energy. The second field is in rural area, we need to enhance the development and utilization of solar thermal PV in rural areas. The third is rural living alternative energy source, renewable energy. The fourth is in the rural area. We need to boost building energy saving and energy efficiency improvement. The fifth is to explore and establish the carbon transaction policies in the rural energy industry. So in 2030, while realizing carbon peak, we need to do the aforementioned 5 tasks, so that we will try our best to lower the energy emission. So this is the first stage. While in the second stage, with the target of carbon neutrality, we need to construct zero carbon village. Here, with MARA and UNDP, as well as GF, very soon in China, we will start the zero carbon village pilot in China. So with villages as a development unit, we will adapt to local conditions to develop renewable energy in rural area through advanced energy saving and energy storage technologies and comprehensive management model, so that we can realize sufficient sustainable supply of regional green energy to reach the zero emission target in the region. So there are mainly improvement in efficiency, energy saving, and renewable energy substitute. There are 3 pathways, so that we can develop zero carbon villages. Construction goals of zero carbon towns and villages in China. Now we have confirmed 4 areas, including development of policies and technology support, including renewable energy technologies and application demonstration, including popularization of lifestyle and knowledge, and also the development of the industries. The principles for construction of zero carbon towns and villages, there are 5. The first is to adapt to local conditions and the multi-complementary development. The situation in China is very different in different places. So this is the first principle. The second is REEC priority. And then energy saving is the most important priority. The third principle is systematic design and comprehensive management. According to different regions and different villages, we'll have systematic design for integrated management of the rural energy utilization. The fourth principle is government-led and market operate. With the leadership of the government in the future, the zero carbon towns will realize sustainable operation with market operation. Then we will need a demonstration, and then to develop step by step. Very soon, we'll organize the pilots of zero carbon towns and villages. And nationally speaking, first we will have low carbon towns and villages, and then gradually moving towards zero carbon towns and villages. The content of zero carbon towns and villages, there are 3 areas. The first is distributed energy system. The second is energy saving and energy efficiency improvement. The third is to build a zero carbon rural society to allow farmers to participate. This is a very important agenda to conduct the education, communication, to build a institutional foundation for zero carbon society. Finally, for the zero carbon towns and villages development, we have an important content to develop, that is to enhance a rural distributed energy integrated management system using big data, IoT technologies to build regional energy integrated control center and a service platform to connect power system, heat supply pipe network, gas pipe network, and a transport network to build a regional integrated energy system so that we can have an interconnection of multiple energy with deep integration with power grid load and storage to realize our target of clean and low carbon, safe, reliable, smart, flexible, economic, and high efficient. So we'll introduce advanced energy management system. This is a very important technology measure to build zero carbon towns and villages. So the rural energy industry, in order to have good development in the next 10 or 40 years, and to realize carbon peak and carbon neutrality target, we need to use advanced technologies to serve the revitalization of the rural areas. Thank you very much.
And I'd like to thank Mr. Wang for your remarks. Now the floor is given to Dr. Von Hippel. He will be talking about sharing of low carbon development technologies and experiences in rural areas in the U.S. He is an independent consultant and he has been working for ADB recently on building climate resilience and climate change mitigation. And also, he's the international expert of ADB project on clean energy supply patterns in Beijing, Tianjin, Hebei region and the surrounding area. Much of his work has also concentrated on energy and environmental issues in Asia, and in particular Northeast Asia, at the regional and national level. Now the floor is given to him. Let's welcome.
Thank you, and I'm happy to be able to join you. Is my screen clear?
It's on portrait mode, Dr. Von Hippel. Can you try again?
How's that? Is that better?
Yes, thank you.
Okay. I'm happy to be able to join you for this forum. And what I'd like to talk about today is sharing of low carbon development technologies and experience in rural areas in the United States and internationally. So what I'm talking about today is some of the benefits and challenges and strategies for applying low carbon and renewable energy systems in rural areas, some renewable energy trends, key technologies for renewable energy use in rural areas, including non-electric rural renewable energy systems, rural located renewable energy systems, both for central grid and for mini and microgrids and standalone, and then heat and fuels based on renewable energy. And then I'll provide some conclusions. So there are a number of different benefits that low carbon and renewable energy systems provide. This is beyond, of course, greenhouse gas emissions reduction. They provide new sources of revenue and thus increase the tax base in rural areas to provide services for rural communities and provide additional stable income for farmers and landholders. They provide new job and business opportunities, especially when many actors are involved. And renewable energy activities are embedded in the local economy, so that's very important. They spawn new innovations in products, practices, and policies. They provide capacity building and community empowerment. And they provide affordable energy by providing rural regions with opportunities to produce their own energy and thus control their own costs. Some of the factors that can support or impede rural energy deployment, renewable energy deployment in rural areas include to support these systems, having a high quality renewable energy resource is very important, of course. Having relatively expensive current energy so that it makes sense to switch. provision of small subsidies to allow rural residents to take advantage of these options, ability to link renewable energy to existing economic activities such as agriculture or mining or small industries, good existing energy and transport and transmission infrastructure, strong local community support, integration of renewable energy within a broader energy framework, mature technologies, reliance on regional inputs that have limited current uses or that is that renewable energy complements existing input uses, and policies aimed at producing inexpensive energy, cheap energy. Impeding renewable energy would be low to moderate quality resource, a low cost conventional energy which reduces the incentive to adopt renewable energy. Provision of large subsidies makes it difficult. Renewable energy is a standalone sector within the regional economy as opposed to being integrated. If a project produces stranded energy that cannot be exported, so we need to make sure that the energy that is produced can be used. If there is significant local opposition, it's an impeding factor. If there is an inadequate backstop energy for intermittent power sources, that is if wind or solar energy is not available, is there some alternative source of electricity, for example, that could be helpful? If it's a new or infant technology, it may be difficult to apply in a rural area. And if the inputs have high opportunity costs, that is, are being used extensively for something else, or if there's an excessive focus on job creation that absorbs public resources that could be better spent connecting renewable energy to the rural economy. An OECD study suggested the following strategies, that is, embed strategies in local economic development, reflecting local potential and needs, integrate renewable energy within a larger supply chains in rural economies, limit subsidies in both scope and duration, and only use them that are for renewable projects that are close to being viable in the market, avoid imposing types of renewable energy on areas that are not suited to them, for example, those that don't have the adequate resources or even training to use them. Focus on relatively mature technologies, create integrated energy systems with small grids to support manufacturing, recognize that renewable energy competes with other sectors for inputs, particularly land, so they may not be compatible with tourism in some areas, for example. Assess potential projects using investment criteria, and ensure local acceptance by ensuring clear benefits to local communities, by engaging them in the process. Some of the key technologies for renewable energy use, some of these were presented in Mr. Wong's presentation just now. Heat from wood or biomass-fired boilers or furnaces, combined heat and power, CHP, for example, can do both power and heat. This has been used for many decades, probably over 100 years in many countries in the food processing, lumber, and pulp and paper industries, can also serve rural factories, clinics, and hospitals with heat and hot water. Active or passive solar technologies can also supply space and water heat. In terms of gaseous fuels, of course, China is a world leader. Methane and carbon dioxide are produced via anaerobic digestion of substrates such as animal manures, human waste, crop waste, or other biomass. This is done in either closed reactors or it could be done in covered lagoons, and which capture the gas produced. Sometimes these covered lagoons are less expensive for large reactors than closed reactors. And it also results in reduction of methane emissions, which is an important co-benefit, of course, for greenhouse gas emissions. Producer gas, or syngas, is produced thermally from a wide range of biomass materials. It can also be produced from coal via thermal gasification. The resulting gas is rich in hydrogen and carbon monoxide It can be burned directly as a fuel or reformed to other fuels such as methane, methanol, ethanol, or converted to electricity. Gasifiers are available from very small sizes, such as for residential use, to very large industrial sizes. And these also, some configurations of gasifiers can be used to produce biochar, which is a soil amendment and also a means of storage of carbon for taking carbon out of the air. Wood chips is another source of solid fuels that are widely used in the U.S. and elsewhere, used as space heating, as inputs to space heating or water heating or electricity generation. Starts with whole trees or pruning waste or forest thinnings and residues that are shredded or chipped and transported in vans, truck trailers from harvest sites. They're sometimes dried, and they can be used with automated boiler feed systems or gasifiers. Wood pellets can be produced by extruding dried ground wood chips or other biomass materials through dyes that produce these solid and very uniform pellets. And the advantage here is that they can be sold easily in bags for rural residents to use, and they can be used in automated systems at the residential and commercial scale. The electricity generation, of course, is in wide use. There are large arrays of wind turbines that are becoming commonplace on windy farmlands and rangelands worldwide, including, of course, in the United States. I just drove across the country, and there were many places where we had large arrays of wind power turbines with many more to come. Wind turbines use only a small portion of the land on which they are sited, just for bases and roads, and they provide stable income for landowners and jobs for installers and for maintenance. Agrovoltaics is another type of technology that is very much being adopted in lots of places. They use special frames to site PV panels on croplands, rangelands, and other areas. This is a rice paddy. They don't interfere with cropping or grazing. It can help to optimize light inputs for crops and provide shade for animals. There are some variants of these that can be tilted so as to optimize the amount of light that a crop gets. They also provide stable and additional sources of incomes for farmers and provide installation and maintenance jobs. Standalone mini and microgrids are designed to provide local power with interconnection to the grid, and they're typically configured to supply local power needs first, and then use the central power grid for backup and sell power to the grid when there is an excess. Some of the reasons for adopting these mini grids include the desire to use local resources to reduce and control electricity costs, to improve reliability, including resilience to climate change. If the main grid goes out, they still have power, to add another stream of income through power sales. Mini grids in remote locations served by the central grid can also help to stabilize grid connections and reduce transmission losses. It's a long way to the central grid. Off of the main grid, mini and microgrids can be used in places such as islands and very remote locations where connecting to a grid is impossible or prohibitively very expensive, and power from the central grid or where power from the central grid is unreliable or of poor quality. Microgrids or even smaller energy home systems, solar home systems, for example, can be used for residential compounds or other buildings in isolated locations, including holiday homes. You may use battery storage or pump storage hydro store electricity. In the future, hydrogen or ammonia actually may be produced when excess electricity is available and turned into electricity when using engines or fuel cells when demand is greater than renewable generation. This is an example of heat production from electricity. This particular example shown in the figure uses renewable electricity which is converted to heat using a heat pump efficient heat pump with hot and cold reservoirs, which then can be converted back via a turbine to electricity. But the heat itself can be used, and heat can be stored for hours or days or even weeks in some cases when solar or wind power is plentiful, and then used when needed during cold days during the winter, for example. District heating can also provide can be one major use, but also a year-round use, such as water heating for dairies or heat inputs for agricultural products. High-efficiency heat pump can be used for conversion and can be coupled with refrigeration or electricity generation systems. Another key option here is our non-electric fuels provided by electricity. Here you're using renewable electricity, such as to produce clean fuels, such as green hydrogen, methane, made from hydrogen and recycled carbon dioxide, ammonia, which is made from nitrogen in the air and hydrogen. And these can allow these renewable energy systems to be stored indefinitely at any scale. So this large dark blue bubble on this graph shows that a very large that these can be stored for weeks or months or years, and span a very large range of power systems. Hydrogen can be produced by electrolysis of water, producing hydrogen and oxygen. It's a clean fuel, can be burned to generate electricity in an engine or turbine, converted to electricity directly in a fuel cell, or compressed for storage, or stored in metal hydrides for vehicles. Ammonia is an interesting fuel, and it's very much of interest in the areas of the United States where ammonia is used widely as a fertilizer, and therefore there's infrastructure such as pipelines and storage and sales infrastructure that are readily available. It has physical properties in terms of its density and how it is stored, similar to bottled gas or liquefied petroleum gas. It's a key input to fertilizer, and thus has the potential to improve agriculture. You can convert any of these electricity to any of these fuels, and this provides flexibility for rural renewable energy markets, such that when electricity prices are low, these fuels can be produced and stored for sale or for use later. Ammonia from electricity, again, can be produced with electricity from ammonia from electricity can be produced with electricity from electrolysis using the Haber-Bosch process, which has been around for 80 or 90 years. There are yet to be commercialized electrochemical synthesis routes for ammonia that maybe someday allow direct production of ammonia from electricity, water, and air, and those may be highly interesting. Renewable ammonia can offset production of ammonia from fossil fuels and can offset imports. Offers renewable electricity in rural areas, producers the option of storing energy as ammonia when markets aren't favorable. And at the provincial, county, or town or enterprise level, ammonia can be made locally and used as a fertilizer or to power transport machinery or agricultural machinery or reconversion to electricity. So some quick conclusions. Renewable energy can be used to provide new job and business opportunities involving many actors and to embed renewable energy activities and jobs in the local community, retain rural populations, and reinforce rural communities. It can provide new sources of revenue, increasing the tax base to provide services for rural communities and stable incomes. It can spawn innovations in products, practices, and policies. It can serve electricity and heating end uses and produce fuels for storage and other uses, as well as fertilizer. Wind and solar systems are compatible with agriculture and thus don't have to displace farming operations. Establishing renewable electricity standards with with shares increasing over time at the national level, is a kind of policy support that's needed here, as well as feed-in tariffs, guaranteeing grid access, improving forecasting of renewable system outputs, and policies such as carbon taxes and carbon trading may help, and support for research and development, as well as providing access to financing and guarantees for renewable energy adopters. Thank you.
Thank you, Dr. David Van Hippel. Now let's welcome Mr. Fang Fang, General Manager, Beijing Borui Environmental Engineering Corporation Limited. His topic is Clean Energy Supply Model in Beijing, Tianjin, Hebei, and surrounding rural areas. Mr. Fang Fang is mainly engaged in rural renewable energy, agricultural resources, environment protection, policy research. He participated in the National Agricultural Non-Point Source Pollution Prevention Project, Agricultural Wild Plant Protection Project, Invasive Biological Control Project, Rural Biogas Project. He has participated in the implementation of international environmental conventions, such as Framework Convention on Climate Change, etc. Now let's welcome Mr. Fang Fang. Distinguished leaders and guests, good morning. My topic is Clean Energy Supply Model in Beijing, Tianjin, Hebei, and surrounding rural areas. I will talk about the following areas. The first is consumption features in this area and clean energy technology analysis and suggestions. The first, Beijing, Tianjin, and Hebei and the surrounding area is one of the most important metropolitan areas in China. It's also one of the three important economic growth pillars. The GDP accounts for 1/3 of GDP development in China. Arable land area is 10% of the arable area in China. My topic is clean energy supply model in Beijing, Tianjin, Hebei, and surrounding rural area. I will talk about the following aspects. The first is consumption features in this region. The second is analysis of rural clean energy technology models. The third is some suggestions. This region is one of the important modern metropolitan areas in China and one of the three important economic growth polars, with Beijing, Tianjin, and Hebei as the center, and covering Shanxi, Inner Mongolia, Shandong, Liaoning, and Hunan. The GDP of this region accounts for about 1/3 of the whole country. Total land area accounts for more than 10%, and cultivated land area accounts for about 25%, and population accounts for more than 25%. The rural population accounts for 45%. The first is large rural energy consumption. In this region, the rural per capita commercial energy consumption is 270 kilogram standard coal, and Hebei, Hunan, and Shandong has very high household energy consumption. The second is irrational structure of rural energy consumption. There's a very big difference. Generally speaking, coal and power are the major power. New energy consumption only account for 6.21%. Clean energy accounts for a very low proportion. We need to further improve the rural energy consumption structure. The third is rural energy consumption leading to high environmental pressure. There's a major supply gap. Here, we have higher requirement on more utilization of clean energy, but now the consumption of clean energy in this region is quite low. The second is analysis of the main technology models. The first is coal to electricity. This model is a very effective pathway to solve the problem of direct carbon emission from scattered coal and coal dust pollution. Now we have renovated 6,000 villages, about 2 million households. There are three types. One is direct heating, the second is heat accumulating type, the third is heat pump. In recent years, heat pump technology has been widely promoted in the process coal to electricity technology application, especially the air source heat pump technology. In Beijing, for example, about 2,000 households using ground source heat pumps, 44,000 households using storage heaters, and 150,000 households using air source heat pumps, accounting for 76.28%. The second is coal to gas model. Now, Beijing, Tianjin, Hebei region and its surrounding area have completed 3.47 million households transformation of coal to gas. So the features is high efficiency, low energy consumption, convenient, relatively mature technical equipment, simple operation. There is a pipeline gas supply, LNG supply, and CNG supply. Well, this is a solar thermal utilization technology model. Beijing, Tianjin, Hebei region and parts of surrounding rural areas are rich in solar energy resources like Inner Mongolia, northern Hebei, etc. This is solar plus electrothermal device heating model. So there are different solar development models. The fourth is solar energy plus biomass furnace. So it can have better utilization of straw with high quality supply of the energy. Well, with traditional scattered coal, by using solar energy, it can cover more areas where a traditional pipeline cannot reach, which can be used for cooking as well as heating. But the investment is high with long return period. This is the situation in Hebei. The fifth is by using the straw with low cost, with a lot of supply of raw material. This is in Tieling, city of Liaoning province. And this is rural biogas technology model. The seventh is rural household clean stove technology model, improving the energy efficiency of traditional stoves or furnaces. Now in China, there are various stoves. This is a rural building energy saving technology model, building energy conservation in rural areas, including the building thermal insulation simulation. And here we have some suggestions. We are enhancing our policy support with, this is one suggestion, to promote and lead the development in this region to better utilize renewable energy. The second is to expand financing channels to fully utilize the government fund like ADB and other international financial organizations are participating in the development in this region to use better clean energy. Promoting rural clean energy infrastructure transformation to better utilize the resources in this region, considering the specific features of this region, like using methane, solar energy, air source pump, etc., and to accelerate the utilization of biomass energy in this region, combined with renovation of coal furnace to better govern and treat the scattered coal. And we need to better utilize the biomass. The fifth is to implement rural renewable energy alternatives in villages in the region, with villages with capabilities to connect to the natural gas pipelines. We need to use pipelines for heating. We need to use clean heating method, especially using clean power sources. The sixth is low carbon villages. With a background of carbon peak and carbon neutrality, combined with the features of this region, we need to point out a clear industrial development direction to use energy saving, renewable energy industry development, and a scattered energy system. The seventh is to boost the rural clean energy industry, to formulate relevant standards for the industrial development of the clean energy in rural area. We need to incubate the clean industry and to develop an industrial system. Thank you very much. Thank you, Mr. Fang Fang. Our next speaker is Mr. Atsumasa Sake, Senior Energy Specialist from ADB. Now he is leading the implementation of ADB's Technical Assistance Project for Low Carbon Energy to promote rural revitalization. This project aims to improve living conditions in rural areas through the deployment of renewable energy, including creating jobs and improving air quality. He also cooperates with Gansu Province to implement a green development project in rural area with the value of $300 million. He has rich experience in promoting rural renewable energy development. Now let's welcome Mr. Atsumasa Sakai to talk about ADB's experience in rural revitalization and renewable energy development.
Because there are some technical issues. Now we are giving the floor to Mr. Wang Mingtian, Deputy Director, China Architecture Design and Research Group, Urban Planning Group, study on guidelines for construction of green and low-carbon small towns. He has been engaging in regional and urban rural planning, design, and scientific research for a long time. His main research directions are regional planning, land space planning, urban master planning, and green village planning and construction. He was and also he is the executive editor of the Small Cities and Town Construction, and he was awarded the honorary title of the top 10 outstanding young people in China design industry in 2015.
Distinguished leaders and dear friends, good morning. Today I'd like to talk about the standard for green small town development. I will talk about three areas. The first is a brief introduction of the background. The second is some fundamental work. The third is the main contents of the guide. After 2015, China has entered into a new development stage with green development idea, including target of carbon peak and neutrality. Now we are adjusting the development structure in China. With this backdrop, we need to rethink about the development of the 20,000 small towns in China. So how to transform the development of small towns? Small towns is the smallest spatial unit in China for green development. It is also the most basic space unit for rural revitalization and new urbanization. It is also the basic spatial units to implement territorial space planning and to optimize the three major spaces of ecological production and living. There are a series of reforms in China providing some policy environment for development of green small towns, like with the administrative system reform, Well, regarding laws and regulations, there is a rural revitalization promotion law for comprehensive development in the rural area. And in the system for territorial space governance, towns and villages is the final level in the territorial space planning in China. With this background, we really need to build a suitable technical standard. Just now, leaders from Mara talked about zero carbon villages, and here we are talking about this from the technical perspective. Regarding the fundamental work, since the 1980s, we already studied the research of green towns and villages. There are several concepts, including ecological towns, low carbon towns, and green towns with different focus. In the end, we chose green small towns because it is more comprehensive with policies to support, which also covers some contents of ecological towns and low carbon towns. With close to 20 years of development of all ministries, like Ministry of Ecological and Environment has been promoting the national ecological towns. Ministry of Housing is doing research on green and low carbon key towns. And Mara is working on beautiful countryside. Ministry of Technology is working on technological innovation in green and livable villages and towns. And the Ministry of Natural Resources has this comprehensive land consolidation, which also involves some topics of green small towns. Here we have an application of the national level ecological towns and villages. This is there are some documents issued by Ministry of Environment Protection involving all areas. Also, together with the UK, we are conducting the pilot of the green low carbon key small town development evaluation standard, including 7 dimensions. Based on the aforementioned foundation, combined with the latest policies, together with the Ministry of Ecology and Environment Protection and MARA, here we are building a general framework, including 10 parts. The first is strike a balance between planning and development. Here we have local, social, and economic development with the bottom line of environment protection and resource utilization. So for those ecology and rural bottom line, this has to be guaranteed. In the beginning, we have problem orientation, and in the later stage, we will have project building oriented method, so that we will do the work according to the targets. Well, we have 8 areas regarding the system. The first is to implement according to the requirement in the planning, and then stick to the ecological bottom line. Well, we need comprehensive land integrated consolidation and treatment. Well, in regard to the ecological environment, the first step is a positive and a negative list to eliminate industries with high pollution and high energy consumption. And then we need to build green parks to accelerate the green transformation of the agricultural, industrial, and service type parks. The third is integrated development of primary, secondary, and tertiary industries with the circular economy as the guidance. Well, regarding green living environment, we need green and landscape development in the villages and towns, in housing service to avoid overinvestment, so as to build living circles meeting the requirement of the times. Then we have 2 categories of living environment according to the National Green Living Area Standard. The fifth is resource utilization to optimize resource allocation to guarantee the land and water usage for the ecology. The second is intensive utilization of high efficient usage of water, land, and mineral. The third is resource utilization of waste. The production and the life in rural area, we need to have circular utilization of the waste. Clean energy. The first is the control of energy consumption. To control the total energy consumption, develop renewable energy. And in all areas of life production, we need to further renovate and improve the energy saving devices. For green building, ministries in China have been considering the development of green buildings in rural area. The first is strict building standard, including housing, industrial, and agricultural buildings. The second is to increase the green building proportion. Now we don't have a standard for green building in rural area. The third is to encourage the rural building to use local renewable building materials and resource utilization of building waste. Infrastructure. We need to encourage the sharing of the infrastructure to avoid waste. The second is green infrastructure, including a rural green pathway to protect habitat, to avoid flood and drought, etc. Green transformation of infrastructure like transportation, water conservancy, urban rural municipalities, etc. The ninth is smart management with digital rural development, improve the digital platform development. Now in Anji, in Zhejiang, we have done some pilot work, and then through grid management model, we can better monitor the various projects. Finally, based on the aforementioned points, we advocate all parties to participate for cooperation and the realization of the green actions. We advocate for the co-participation by government, enterprises, social organizations, and the public to participate in the development of green small towns. So that's all for me. Thank you very much.
Thank you very much, Mr. Wang. Now the floor is given to Mr. Chen Wenbo, President, Senior Engineer, Nanjing Guocheng DC Power Distribution Technology, and he will be talking about the application of PEDF technology in rural areas. He has been engaged in the low-carbon DC transmission, and also he is the Vice President of IEEE PES, and he has 21 national patents and has published more than 20 papers home and abroad and received 5 awards of provincial scientific technological advancement awards and has been involved in making 5 standards. So let's welcome. Distinguished leaders, it's a pleasure for me to have this opportunity to share with you the rural PEDF system in the context of rural areas. So can you see my screen now? So we have done a PEDF pilot in rural areas in Yuncheng Village, Ruicheng County, Zhuangshang Village, Ruichen County is the first one in China for the pilot of the whole county picking. And we can see that in Zhuangshan village, it is a very traditional Chinese village. We have cave dwellings mainly. And in the 70s and 80s of last century, the rural villages actually abandoned their cave dwellings and now live in rural housing. And we can see that it's actually at an ancient port, but with the decreasing rural population currently, it's like a dilapidated village with wasted biomass energy because they actually did not burn the straws anymore, and we can see litters everywhere and dilapidated cave dwellings. They used to burn coal, so there were many poorly managed piles of coal. In line with the revitalization of the rural area, we need to improve this. And we need to start from the energy revolution. What we are doing, we were promoting the PEDF system in the rural areas so that we can electrify the power system. And after that, we can turn waste and straws into commercial energy and to feed in back to the power grid to be transmitted to urban areas. It's a huge challenge. We started in 2019 actually. And in village, we established a 27 household low voltage DC system, mainly using PV solar energy for domestic and production usage. So whether we are testing whether this technology is viable there and whether it is affordable enough, and then we can promote them across the village. So what is a PEDF system? It's a direct current microgrid system. Actually, P refers to distributed rooftop photovoltaic. For photovoltaic, the density is not that high. If we use centralized PV, we need lots of land. We now have about 20 billion square meters of roofs in China, and many of them are in rural area. If we can put rooftop PV panels on all the roofs, it can save a lot of land. And for energy, it means distributed energy storage, and it also can refer to energy storage, heat storage, and even H2 storage. So D means DC power. It can better accept or absorb new energy sources. Whereas many of the appliances now can be powered by DC, DC can be a necessary link in the system of the grid. Compared with AC, DC can provide better quality, reliability, while using renewable energy or new energy, and it can reduce the operation and maintenance costs. The state grid had done a lot of research on this. For DC, it can help us a lot because AC posed a lot of challenges. DC is more cost effective. F means flexibility, flexible load. Currently, in urban and rural areas, more than 80% of the appliances can accept both DC and AC. Only a few air conditioners and refrigerators use AC, but we can adapt them easily to accept both AC and DC. For the architecture, The aim is to link the microgrid and the central grid in a flexible way, because AC, its power grid, it's rigid, but with DC, we can decouple their source with their grid. For the future new energy grid systems, this flexibility is very valuable. This is the entire architecture in the village. We have 3 power transformers. It can accept 220 V voltage of DC, and for every household, its load are connected to the main grid. For the DC 220 voltage can be used in smaller villages, but for large village, according to standard adaptation, we can adopt DC 750 voltage, because this can largely reduce the transmission loss. And we have done a case study in Anhui. Many of their PV, when they're using DC 220, the transmission losses will be 16% at the village level, but if we adapt it into DC 750, the losses will be less than 500. So then the renewable energy power can be fed back effectively into the main grid. And in this way, the installation of the new energy can be larger than the demand for the. And in this way, this can help us a lot to achieve our goal. And for the excessive supply of energy, they can be used in their homes or be stored. So this will reduce the investment from the state grid to incorporate renewable energy. The state grid has done a research. Actually, we have more than 100 million kilowatts of renewable energy from rural areas, which requires investment of 270 billion yuan of state grid. But for the distributed new energy, the rural areas, the household actually need to enhance their investment. And if we use our system, it only needs about 70 billion yuan, so which is only almost 1/4 of the estimated original cost. So home appliances, many of the appliances can use both AC and DC, including rice cooker, phone charger, laptop, heater, refrigerator. They use both AC and DC. The pure resistance heating appliances need to be adapted. We need to add an active arc extinguishing module, because using DC it will create a large arc, but with the arc extinguishing module, it's very cost effective for the kettle. It just requires like 10 yuan in additional investment. And in northern rural areas of China, many of them use graphene heater. It's also a bus load, and we can see on the left-hand side corner, it has a arc extinguishing module. It's about 10 yuan per unit, and many of the appliances can use this to accept DC, and we can update the electrical tricycles. And then when we have enough power, solar power, we can charge the electric tricycle. It can store 5 to 6 voltage of light, of power. So it's like a ultra low voltage DC off-grid system, and this can power many of the appliances or also agriculture machinery, including pump, the spreader, the sprayer. So this off-grid system can help us to turn coal and fuel burning into electricity using, and this can reduce 1,000 to 2,000 in cost of fuel for every household in every year, and this is quite popular among the rural residents. And using this tricycle storage, so if it still have power, we can put them back to the off-grid system so that we can use tricycle to power the homes. And we also established a zero carbon campaign. Many of the power used are from PV and biomass stove. So it's zero carbon. Now it's on commercial use, and we hired 4 local people. So we are also striving to create more jobs besides low carbon and zero carbon development. And this is Pvdc irrigation and rain harvesting using a PV-powered pump for irrigation for the surrounding farms, and also the trees and grasses is quite popular. And also we have the monitoring control of PEDF system. We can use the WeChat mini program for monitoring, and they can see their power generation as well as power usage, and we can have village level monitoring system. It's like a driver cab for the entire village's PEDF. And we have established 27 households like this. They used 220 VDC with the unipolar wiring, IT grounding. So we can see the PEDF in their homes like this. Besides power grid enrichment, we have also explored the off-grid system. We use PEDF for off-grid operation, especially for public toilets, public bathrooms, as well as observation decks. And this is also very meaningful because in some mountainous regions, the long-term high voltage power transmission only serves a few households, but the maintenance cost is much more expensive than the utility fees. So we can use this to update the transmission system for remote areas, and they are using DC for EVs, and they can use this for rice cookers as well as lighting. This demonstration from 29 to now, 15,000 visits are made to our demonstration sites. Besides clean rectification in line with the local culture, we also have done some cultural promotion, and we believe it can be a pilot for building a beautiful village in China. The ultimate goal is that we hope that the domestic and production power will be electricity, and the surplus biomass and waste can be turned into commercial products and then to be sold back to urban areas so that we can have clean waters and green mountains in rural areas. So this is the night view. We can see this is the Yellow River, and we can have lighting through PV power. It's now a tourist attraction. Every day 100 or 200 local residents will take a walk or enjoy the view here. And it's just at a starting point, but it has attracted wide attention from Shanxi Daily and other official medias, including China Daily. And many academicians also visited our pilot program and offer us many valuable suggestions. In our whole village promotion, we still have some breakthroughs to make in technology as well as policies and pricing. Standards, pricing, policies still lag behind, but we are striving to promote this system. The state grid is also actively promoting PEDF system and formulated their rules and the standards to adapt such systems based on our pilot. For PEDF to be promoted nationally, we need to have the industrialization of key technologies. We need to lower the price further. And globally, we have 1 billion people with no access to power. PEDF can be a cost-effective and friendly new energy system, which can provide access to power to these 1 billion people at a lower cost. So this is my presentation. Thank you very much. Now the floor is given to our expert from ADB, Atsumasa Sakai, for ADB's experience in rural revitalization and renewable energy development. Senior Energy Specialist from ADB.
My name is Atsu from ADB, and thank you very much for giving me this opportunity to present in this wonderful forum. And today I will share the ADB's activities in the green rural development. Now, we are administering the knowledge and support technical assistance for the green rural development, and also we plan to finance a green rural development project in the western part of China. So these are today's topics. First, let me brief the ADB's activities in the climate finance. This slide shows the snapshot of the ADB's activities in the climate financing in 2020, last year. We have invested around $5 billion last year, which covers not only the climate change mitigation activities, but also the climate adaptation activities. The sectors that we have covered is not only the energy sector, but also the agricultural sector, transport sector, and also the development of the urban and rural areas. And last week, we decided to increase our target more higher. And we set the target of the climate finance amount up to the $100 billion up to the year 2030. This table shows the major ADB projects in China for the green rural development. We have the financed biomass project as well as the hydropower project before, and we have conducted the multiple studies in the rural green energy development project. sometimes in the greater Beijing-Tianjin-Hebei region, and sometimes in the Sichuan province. Today, I will present the ongoing KSTA, the customized low carbon development models in rural and small and medium-sized towns. And this study has been approved in December last year. The project's executing agency is National Energy Administration. And this technical assistance aims to increase renewable energy intervention in rural areas and increase low carbon modernized energy supply in small and medium-sized towns. The technical assistance has two components. One component targets rural areas, and another one targets small and medium-sized towns. And both components aim to develop a customized green rural development model. So as already explained by the other distinguished speakers today, the clean energy development or the low carbon energy development is a key to the success of rural vitalization in China. According to the recent news article, the Shandong province has succeeded in improving the living condition of rural areas and increased the annual household income per capita by 76% from 2016 to 2019 by leasing farmland to solar power projects. And the beauty of this approach is the increased revenue will be further invested into the future rural development, such as the development of the local infrastructure. So the project brings a sustainable growth to rural areas. The news article concludes by saying that clean energy is becoming a green engine for the rural vitalization. From the international community, like the OECD, the renewable energy would offer rural areas many benefits. That includes new revenue sources, employment opportunities, innovation, and affordable energy. So having seen this benefit, this technical assistance aims to further improve the cost-benefit performance. As you can guess, the profile of the rural villages varies from the north to south and from east to west. So therefore, by customizing the development model to such a local conditions, we can further improve the cost-benefit performance and make the project further financially sustainable. Possibly, it will be possible without having the government subsidy. So therefore, this technical assistance aims to propose optimal rural development model with low carbon energy supply. And considering the intensive past studies in the technical aspects, this study pays more attention to non-technical aspects, such as the local commercial terms, policy and regulation environment. The technical assistance consultant has been mobilized since July 2021. They have already selected represented rural villages, one from the north in Gansu province and one from the south in Hunan province. And their survey is ongoing, and they are collecting data such as the climatic condition and geographic characteristic, energy consumption behavior, and also the local commercial terms and the regulation regarding the financial resources for such a rural energy development. Their interim result is expected next year in March, and we would like to announce the workshop further. So ADB can add value to these activities by having the international best practices. We have the multiple resources to bring international best practice to the study. One of them is this Asian Clean Energy Forum. We organize this forum every June over the past 15 years. We have invited distinguished international speakers from all the world to let them to share their experience and lessons from their activities. And these distinguished speakers have attracted more than 3,000 participation over the world last year. And this slide shows some sample innovative business models proposed by a distinguished speaker. They proposed this business model, such as the district scale energy project, to reduce the cost of the development. They also proposed to mitigate the risk of the investment cost by sharing upfront investment cost between the district energy developer and the integrated energy service provider. And another ADB resource to bring international best practice is the international consultants. So here I present some initial findings from the TA's, the International Consultants Literature Review. And from the United States, the electrification in rural areas in early 1920s has changed the lifestyle and economic activities in rural areas. That is, the transition from the sole agriculture activity to the urbanization. So therefore, we expect a similar lifestyle change could happen by energy transition to the renewable energies. From the case of the Denmark, the country has succeeded to promote the renewable energy sources, mainly the wind power generation, by taking the collective ownership approach. And Danish government has created incentives such as the partial investment reimbursement, tax reduction, and the generous feed-in tariff to promote these activities. Thanks to this approach, now Denmark is one of the advanced renewable energy countries in the world. So Japan has also promoted the renewable energy development in rural areas in the past 10 years. And because of that, they have achieved a much share of the renewable energy sources in the country. But the current issue includes the fact that the profit from the renewable energy development flows out from the local community. This has been resulted from the fact that most of the renewable energy power plant owners are from the non-local enterprises. So therefore, in order to retain the profit in the local community, the local government is considering to put the regulation or policy to let only the local enterprise to run the renewable energy business, or at least to team up with such a local enterprises. And from the case of Australia, we can learn the agri-solar concept. So this concept aims to not undermine the existing agriculture activities by installing the solar power plant. Rather, it aims to let agriculture activities and renewable energy development mutually benefit each other. So in this case, by adjusting the design of the solar array, the agriculture production would benefit from the protection from the severe weather condition and also improve the soil moisture. In some cases, the solar array even protects the sheep from the predators. So under these studies, we are going to incorporate these international best practices to develop the customized low carbon energy models in rural villages in northern China and southern China. So the next case study shows the case where ADB will finance the green rural development project. We are working with Gansu provincial government for this purpose, and the government has selected 5 local villages. And this development proactively incorporates green design and aims to reduce carbon emissions by multiple measures. That includes let the building meet energy efficiency standards and electrify the transportation sector, and proactively install distributed renewable energy sources, such as the solar panel mounted street lighting. So by having this green designing, the project expects to reduce around over the 50,000 tons of CO2 annually. And further, the beauty of this project is they tried to utilize the reduced CO2 emission for further future rural development investment by having a carbon credit concept. By having a carbon credit concept, the reduced CO2 emission can be monetized, and this will be used for the future rural development in the country. So this will make another circulation or the loop of the future sustainable development. The Gansu provincial government has also one of the domestic emission trading system in its provincial capital, Lanzhou. And it also has the proven record of the CDM project in the past. So by utilizing these resources, we aim to launch a new type of the green in rural development models for this project. Thank you very much for your attention. Over back to you.
Thank you all for your presentations, which is very informative and inspiring with new opinions, especially facing the carbon peak and the neutrality target. They have made their contribution regarding renewable development and the rural revitalization in China and the UN 2030 Sustainable Development Goal. These presentations are very instructive and inspiring. Thank you very much. So that's all for the first part. Now we'll have 15 minutes tea break. And please come back on time for the second part, that is a panel discussion. Later on, the panel discussion will be moderated by Division Director, Division of International Exchange and Cooperation, Rural Energy and Environment Agency, MARA, Director Wang Quanhui. Rural Energy and Environment Agency, MARA, I'm Wang Quanhui, and now I'll moderate this panel discussion. For low carbon energy access for rural revitalization, today we have 6 panelists. The first panelist is the Division Director, Energy Division, Rural Energy and Environment Agency, MARA, Xing Kexia. The second panelist is Deputy Professor, Institute of Energy, Environment and Economy, Tsinghua University, Chang Shiyan. He has been committed to the renewable energy and climate change research. The third expert is the biomass expert, especially on the industrialization of technologies and market promotion of the technologies. President of Great Resources, Mr. Hong Hao. And online, we also have panelists coming from North China, who has done a lot of theoretic and practical research of the rural renewable energy. Director, Researcher, Black Soil Research Institute of Heilongjiang Academy of Agricultural Sciences, Mr. Liu Jie, as well as the expert who's been working on the renewable energy technology promotion in Hunan province, as well as using ecology to benefit the people. Second-level investigator, Department of Agricultural Resources Production and Utilization, Department of Agriculture and Rural Affairs of Hunan Province, Yin Bangyou. We also have an international panelist who is an expert on the rural electrification, Mr. Pierre Gassel. Well, today's panel discussion has two topics. The first topic is to talk about renewable energy and its relationship with ecology and pleasant living environment, which is an important part in the rural revitalization. So we'd like to invite our panelists to talk about this topic, that is the development of renewable energy and how to boost the rural revitalization and the pleasant living environment. The second topic is facing the backdrop of carbon peak and neutrality, the industrial development of rural renewable energy. How to have a good development of the industrial chain, how to have a market-oriented development. And with the backdrop of carbon peak and neutrality, how to increase the proportion of renewable energy and the flexibility of it. So, regarding the first topic, first we'd like to invite Director Xin Kexia to introduce the renewable energy industry and how can it boost the pleasant living environment in rural area. Director Xin. Distinguished experts and colleagues, good morning. First, a self-introduction. I'm from the Renewable Energy Division of Rural Energy and Environment Agency, MARA. Well, regarding rural revitalization, pleasant living environment is a key. With the CPC Central Committee, there is a rural revitalization strategy. A pleasant ecological environment is a treasure of the rural area. The first, low carbon is a very important part because in this March at the Central Financial and Economic Conference, it pointed out that carbon peak and neutrality is an important part of the ecological development, meaning low carbon or zero carbon is an important part of the ecological civilization development. Well, the rural development here is also a part of the large scenario. So the rural pleasant environment shall be a low carbon pleasant living environment. So the Energy Bureau points out that by 2030, the non-fossil energy shall account for 25%. So we need to follow the steps of the national strategy in rural area. Then to develop renewable energy, we have great advantages because we are rich in the waste like manure, straw, sewage water, and other waste which can be turned into biomass. And we have a great potential for solar energy development. So we have a lot of renewable energy reserve providing very good condition. And then by using our rich organic resources, we can develop renewable energy, which is an important measure for low carbon and pleasant living environment in rural area. For agriculture in the rural area, we have some problems. The first is manure and waste straw and sewage water and other waste. These are very important ecological problems and environmental problems. In the past, we have some measures like resource utilization and the treatment of the environment, etc. On the one hand, these waste resources is an important source for renewable energy. By using this waste, we can handle the environment problem, which can also produce clean biomass energy through methane or biogas. The third is we can have a circular development. We know that we can use methane to produce power for high quality development of the agriculture. So to develop renewable energy in rural area, we can protect the environment to replace the fossil fuels with high quality development in the rural area. So there is a balance between low carbon environment protection and high quality development in rural area. So to develop rural renewable energy can help us to realize a low carbon and a pleasant living environment in rural area. Of course, we have some successful cases like in a rural area in Anhui province. They have a full area bio-natural gas project by using manure, straw, sewage water, waste from rural area as well as some kitchen waste from the cities to use them as a source to produce biogas to strike a balance between the environment, society, and the economy. We forecast that by 2030 and 2060, the rural organic waste resource is very high. If we can use this organic waste to produce methane, we can use 250 billion cubic meters resources. So in 2014, the agricultural greenhouse gas emission is 830 million tons greenhouse gas emission. So in this case, we can. It is a very effective measure for low carbon development. Okay, thank you, Director Xing Kexia. Just now, she introduced the rural low carbon development to promote the renewable energy industry development for urban revitalization. We have achieved something, and she has drawn a beautiful picture for the future. We hope that through the work of the Mara, we can better benefit our farmers for a pleasant living environment. Now let's invite Dr. Hong Hao, Director President of Great Resources. He will talk about how to use biomass resources for the low and zero carbon villages and towns. So let's welcome Mr. Hong Hao.
Thank you very much for giving me this opportunity. So I firstly would like to briefly introduce myself. I have been working this for a long time and I started my work in this sector in 2006. So I've been engaged in this for 15 or 16 years to turn waste into energy, internationally speaking. It's the pillar for renewable energy. Its share is more than 50%. I believe it's quite well known. And we have the several topics for this panel discussion. For rural revitalization, it depends on life and production. Biomass can help rural areas for a low-carbon lifestyle or build low-carbon villages. In terms of lifestyle, we need heat, electricity, cooking energy. Rural revitalization Who should be doing this? Who is the major player? We all aspire for a low carbon life. It's difficult to lead such life in cities because we mainly use fossil fuels in cities, while in rural areas, for low carbon lifestyle based on renewables, it's more cost effective and the cost is lower in the rural area. To lead a low carbon life, it's easier to in rural areas. Firstly, electricity. For future sustainable development, solar and wind will be the major pillars. In renewables, but biomass for energy or power can play a big role as a power source if it has a high efficiency in transmission or conversion into energy. So rural power can come from biomass. And secondly, heat. For agricultural resources, besides production of food, for eating, the waste actually kind of the coal for burning actually come from the agricultural waste. But how can we use it more effectively using the latest technologies for a different impact? So the heat source should come from biomass, in my opinion. Biomass can be a major pillar in this. For cooking and for heating in southern China. I want to share some cases here. Rural heating has some challenges. Unlike cities, we cannot have centralized heating supply because this requires density of population, so that per unit heat loss will be lower. But in rural areas, we live apart from one another. Then what should we do? So we have central heating in rural areas instead of using pipelines. We use transportation of fuels and replacing the old fossil fuels with biomass. And we can use smart monitoring system. So every unit can produce whatever they need. Their production can meet their demand. And then we can have smart, efficient, and modern provision of heat. So in terms of zero carbon lifestyle, I believe biomass can play the biggest role. And thirdly, transport. In terms of transport, replacement of fuel using renewables. Firstly, electricity. Secondly, hydrogen. Bioenergy in Brazil, in United States, are widely used, but it requires high investment in technology and market promotion. We need to strengthen these efforts as well. So in heat, power, and transport, biomass can play a leading role or work as a complement. Thank you, Dr. Hong. He elaborated on the end using of biomass in rural areas for power, heat, and transport. Thank you. Now the floor is given to Professor Chang Shiyan, Institute of Energy, Environment and Economy of Tsinghua University. he will be talking about the sector as well as commercialization. One of the key for rural revitalization is the market in carbon sink, and while developing the sector, we need to promote its sustainable application in rural areas. So now the floor is given to Associate Professor Chang. Thank you, Director Wang. The question is pivotal. Sustainable, renewable sector can have two kinds of implications. Firstly, we need to use market-oriented methods to promote the clustering of such sectors, including labor, land, investments, technologies, as well as data. So in terms of factors, we need to allocate resources to promote renewables. And secondly, in products, we need to promote its commercialization of products. As an energy product, it is very important for economic development, production, and life. So we need to use such products widely for carbon peaking and carbon neutrality. Yesterday, China issued a document formally to comprehensively implementing the new concept for carbon peaking and carbon neutrality. That is the name of the document. So it will be the top level design. So I want to talk about this document as well. In terms of, firstly, the factors. In this document, it mentioned how can we promote all these factors for carbon peaking and carbon neutrality. It involves investment policies and green finance policies, and establish a financing investment mechanism in line with carbon peaking and carbon neutrality. So what should it be like? What are its features? And in this mechanism, what is the role of renewables? Many of the international financial institutes are withdrawing investment in coal-fired plants. So we can understand that which kind of the investment mechanism are in line with carbon peaking and carbon neutrality, and this should be our focus. And also, this document mentioned that we need to encourage banks and other institutes to provide long-term, low-cost finance. And we need to establish a low-carbon transition fund. I believe all this information is very important. So firstly, factors. How can we allocate resources? And secondly, products. How can we allocate resources for the products? In this document, it also mentioned that in laws and regulations, we need to strengthen our efforts, including to revise the renewable energy laws. We need to improve the pricing mechanism for the sustainable and healthy development of renewables, and to establish and improve the carbon trading market in China. Currently, many of the renewable companies cannot trade on this market, but they can use other methods to be involved in carbon trading market. In the national market, carbon pricing can send a signal for us as to guide our investment, consumption, and lifestyle. Renewable products are diversified, including biomass, solar, wind. They differ greatly, and they differ greatly also in cost. So I suggest that we need to have comprehensive measures, especially in factors and the products. We need to promote its commercialization. Thank you. Thank you, Professor Chang. So she talked about this issue from different aspects, including establish a sustainable renewable energy financing system. And also in policies, we need to make more efforts. And thirdly, the pricing and the carbon trading market can help us to commercialize. Thank you. Now the floor is given to Liu Jie from Heilongjiang Province. He's the researcher at the Black Soil Research Institute. Northeast China actually lacks energy, and also the heating in winter there will be a challenge. So the floor is given to Mr. Liu. How to use the bioresources from agriculture for heating. Director Liu, please. Good morning. I'd thank the moderator for giving me such topic. Currently, I'm in Harbin, in the most northeast part of China. In this region, we have already started heating season. The heating season actually lasts for 6 months, so this topic is quite relevant. Before plunging into details, I would like to offer some general suggestions. In northeast China, clean heating requires the store for energy. For clean heating, firstly, in the greater context, clean heating are based on the following aspects, including the 2030 carbon peaking and 2060 carbon neutrality goals proposed by President Xi during September of last year. And in COP15, President Xi reiterated this. And we will need to establish 1+N policy systems for carbon peaking and carbon neutrality in northeast China. In December of 2017, NDRC and other 9 ministries issued a clean heating plan for northern China. In this plan, it proposed that by this year, clean energy should be 70% of total consumption for heating, and we need to phase out the bulk coal burning. For every year, we use about 400 million tons of coal, but the target is 150 million tons.
And also, the clean heating shall reach 60% in rural area, meaning we have some targets. The second is regarding the heating in northeast China. What are the problems? The first is the heating period is very long, and in the rural northeast, they have just like one-story housing status. More than 80% don't have energy-saving measures. So per square meter, it needs about 30 kilograms standard coal. And therefore, clean heating, no matter power or gas, the infrastructure in rural area is not enough to turn from coal to gas or electricity. Right now, coal or biomass heating efficiency is quite low. Safety and environment protection level is not very high. Another obstacle is it is like a double-edged sword. One is urbanization. Right now, the population in cities about 53%, while developed countries is about 80%, and developing countries about 60%. So regarding the process of urbanization, we are still undergoing So inevitably, if we need large-scale clean heating, we need to renovate the infrastructure. There is a cost efficiency issue. We are facing this kind of risk. So this is a very big obstacle for clean heating in northeast China. So facing this background and obstacles I mentioned, I have thought about the pathways. So first of all, we need to based on the existing resources to do the energy saving, we need cross sectors, regions, and industries to coordinately solve the clean heating issue, like building energy saving and waste treatment, toilet revolution. Well, specifically speaking, we need to stick to energy saving to save per unit energy consumption than to use renewable energy. And then we need to mainly consider carbon reduction to realize the target of low carbon or zero carbon. So we need to do the following things. The first is still to promote urbanization. Well, actually, in northeast rural area, well, during the idle period of farming, a lot of farmers are going to the counties to live, to enjoy the centralized heating. And when they are busy in farming, they'll go back to the rural area to care for their farmland. So the migration and the moving of the population can solve this issue on the one hand, and then the energy revolution in rural area also involves toilet revolution and the garbage revolution and other series of activities. The second part is the building energy saving improvement. So on this basis, energy saving, potentially speaking, is the energy revolution with the best efficiency. The third one is biomass energy. You see, only renewable energy that can be burned. So it has some advantages here. The first, it can like to burn it for heating. The resources is available locally. In northeast, in winter, that is the season you can get the straw. We have very mature devices, no matter which category. We have very mature devices. The fourth is regarding emission. We can reduce carbon and pollution. And also another important part is we can use biomass heating to improve the production and life in our northeast and to separate this part. Through these measures, we can have a better integrated management. So we have these advantages. Well, actually, we have done some preliminary works. Now I'd like to share you with 3 cases. The first is for the household, one village, one plant to use the straw. Now we have more than 1,500 straw processing plant to produce about 12 million straw fuel. We have about 130,000 devices. And then for enterprises and government departments and schools, we are also using straw to get very good results. It is easy to implement this, especially like in government institutions. The third case is now we are doing and we are promoting the straw direct combustion. Right now, we have done a very good case. In Hailun County, it is 230,000 square meters straw project. Okay, that's all for me. Thank you, Mr. Liu. Thank you for your sharing regarding the development of renewable energy in northeast China. including the cost, the biomass furnace, and the market orientation of sustainable development and relevant technologies. Thank you, Director Liu. And now let's welcome second level investigator, Department of Agricultural Resources Protection and Utilization, Department of Agriculture and Rural Affairs of Hunan Province, Mr. Ying Bangyo, who has been working on the promotion of renewable energy technologies in Hunan. He is a pioneer in our industry. Now let's invite Mr. Ying to talk about a case in Taoyuan County in Hunan Province. He'll talk about how to use renewable energy to benefit the farmers, empowering the women in rural area. Let's welcome. Distinguished leaders, experts, good morning. Thank you for giving me this opportunity to talk about experiences and learn from other experts. So regarding the question from the moderator, combined with the practices here in Hunan, I'd like to talk about the green and renewable energy and their application in rural area for green and sustainable development, so as to realize the target of carbon peak and neutrality. To solve the energy utilization issue in rural area, improving the life quality, have a very good comprehensive efficiency. Now I'd like to take Taoyuan County, for example. I'd like to give you a brief introduction about Taoyuan County. It is located in the northwest of Hunan Province. This is a large county of agriculture, which is rich in renewable energy, which is ranking top in Hunan regarding the resources. We have a vast reserve of methane. The utilization rate is more than 32%. We have energy saving stoves of more than 52,000 energy saving stoves. The government and the CPC Committee of Taoyuan attach high importance to the renewable energy in Taoyuan County to have wider application and the management of methane, have comprehensive green energy development planning. We have dedicated methane production method and plan in rural area. We have dedicated fund for model innovation and better services. We have a series of demonstration projects. The methane and the solar utilization rate is ranking top in Hunan Province. And now the living environment as well as the demonstration region is also very leading here in our province. The utilization rate of the renewable energy has also been increased a lot. We have solar heaters, more than 100 solar heaters. We are promoting biomass furnace. We have high renewable energy utilization rate with very good effect, helping farmers to increase their household income, saving energy expenditure, reducing CO2 emission, 1.75 tons equals to 0.9 tons of standard coal saving. We are further improving the quality. The output has reached 60 million. And we have further improved the living environment, like the household waste, methane pool, etc., have all been improved. We are better using solar energy to make the travel easier and more convenient and safe. We have also saved the labor expenditure. Well, based on the successful experiences, we have further support from the county financial support, fiscal support, with experts to support. We are sending experts to the households to provide professional services. We are also combining straw utilization with methane, promoting the advanced technologies to combine methane with biomass stoves with a high efficient utilization of the resources. So that's all for me. Thank you very much. Thank you, Director Ying. Well, Taoyuan County is the place with the cherry blossoms written by Tao Yuanming in his famous work. So to build a modern Tao Yuan, you have done a lot of work for a pleasant living environment. Now let's welcome Mr. Pierre Cazares to talk about who is the director of the Rural Electrification Association and director of Global Partners International Corporate Association. Mr. Gaseous is ADB's international policy expert. He's been working in China for 9 years. In renewable energy field, he has very rich experience of the research. Now let's welcome Mr. Gaseous. He will talk about the efficiency improvement issue. And he will also talk about CORE, that is a cornerstone of rural electrification, as well as what we can learn from this case and apply this here in China. Now let's welcome Mr. Gaseous. Let's welcome.
Thank you very much. Good morning, everyone. I'm sorry I cannot be with you physically speaking. I am based in Bangkok. Yes, I work for the International Corporate Association. And yes, the aspect of efficiency is critical in our efforts to bring electricity to everyone, which is in some cases a first step that is necessary still today, and very much in specific places. I would like to say that I am very pleased to hear this new concept of low carbon and pleasant environment. That pleasant environment is definitely the objective that every program should have, because this is indeed what every human being wants to have, a pleasant environment. So why efficiency? Because where we cannot waste resources, and this is also perfectly in line with the concept of eco-civilization. And as far as the rural revitalization and access to electricity is concerned, renewable energy is critical. And we are talking about systems that are delivered to the villages to bring electricity, and efficiency is a way to increase the efficiency that is delivered to the community. So the efficiency aspect is critical. So now, Core, thank you for inviting me to this international conference and give me the opportunity to introduce Core, which I believe is an initiative that could help some of the projects and some of the projects that you are all doing. So I will share my screen, and I have a short presentation. It's 5 slides, really. So it's called Cornerstone of Rural Electrification, and this is really in line with the objective of universal access to electricity for all by 2030. So the key objective of this core initiative is to support and improve the livelihood of rural communities. So this is totally in line with the present environment. And how to do that? It is to ensure that all the decentralized electrification projects, the system, the solar home system, the biogas equipment, meet the highest standards of sustainability. So I will tell you a little bit more about this. So as you can see, this is an initiative that we are leading ICA, but it is implementing in partnership with the Alliance for Rural Electrification, UNIDO, UNEP, IRENA, and Sustainable Energy for All. So again, I will not repeat myself. The scope of this initiative is renewable energy, and its mission is to enable resilient rural and peri-urban communities. And how do we do that? This is our value proposition, is to offer technical assistance. So we have, through our experts and financial support from the International Copper Association, we have experts we can mobilize to deliver technical assistance for free to projects like some of yours. And this technical assistance is related to increasing the safety, efficiency, and reliability of the DRE systems. And this was also mentioned with the previous speaker. We are also focusing on women to empower them on the productive use of electricity. Because for rural development, women really play a key role, and they are really agents of change. So we will work with women as well. So now, briefly, we have a few target groups, and this might be interesting for some of you who might want to know more about CORE and discuss how we could possibly support your activities. We look at practitioners. So again, this is for mini-grid DRE systems. Now we are not working on biogas, but this is for electricity systems, mini-grids based on so decentralized renewable energy, DRE systems. It's to build the capacity of the practitioners on design, to design it the best way to deliver the maximum output, and then on system, on component selections, installation, and operation and maintenance. So another target group is, once there is electricity, then to work towards that present environment, build the capacity of local communities, and again, especially women, on the productive use of electricity. Finally, we also work with policymakers to help them establish national or training and certification programs. Also to improve the policy and regulatory frameworks for decentralized electrification in terms of quality assurance, etc. So how do we deliver this technical assistance? So for practitioners, we have the CORE Academy. So we have online training and certification courses, and we have one is going to be launched in January. We are launching the CORE initiative actually at the COP event in Glasgow. So there will be a series of online training and certification, and that will be on aspects related to safety, design, installation and operation and maintenance. We will improve that library of training materials with videos. Now we are working in Thailand with the Ministry of Energy to support their ambitious target of having 100 megawatts of solar rooftop PV per year until 2030. So we are working with them to design a national training and certification scheme based, and so we have developed the training curriculum for them. This is the kind of technical assistance that CORE provides, and then we will link with the other programs, other resources online where the community of practice can find teaching material. Now, how do we frame this technical assistance offered by CORE? We do cooperate with ongoing projects. As you have understood, CORE is not here to stimulate energy access projects to have more solar PV mini grid systems, but for those projects to make sure that they meet the highest levels of safety, efficiency, and reliability. So we cooperate with projects. Now we are cooperating with projects funded by the WWF, with GIZ and others. We are also going to design new programs, big capacity building programs and technical assistance programs, and then look for funding. And finally, we have tailor-made services. Again, with Ministry of Energy in Thailand, we have agreed on what to do. We could also do this with private companies, installers of such. So finally, who are we? This initiative is managed by the Alliance for Rural Electrification. It's an industry-based, member-based industry association representing installers and designers of renewable energy systems. So they manage the activities related to funding and partnerships. We want to develop partnerships. They manage the core academy, deliver our technical assistance and capacity building programs, and do communications. We rely heavily on strategic partners. So we develop MOUs where we agree on mutually beneficial activities. We also have regional hubs. You can see some logos, mostly in Africa, but it's a global network established by people, but we are also expanding these regional hubs, especially in Asia. And finally, we have a board to advise us on strategic decision and to help us with securing funding and making available their expert network. And this board is composed of ICA, our organization, Alliance for Electrification, who manage this is the initiative, and then UNIDO, SC4All, UNEP, and Agri. And we are launching CORE during the COP. There will be an event there. So you have here my details, my address, p.cazeles@coreinitiative.org. I am the director. And this is our website. And so please go to the website to find out more, and you have ways to communicate with us if you would like to discuss any support. Over to you. Thank you very much.
Thank you very much. Pierre Cazella, Director of Global Partnerships, for briefing us on CORE, its missions, its works. We're very interested in what you're talking about. You mentioned energy access in rural areas, as well as empowering women. Actually, China, in promoting renewables, and has done a lot of work so that farmers and particularly women can receive the benefits. I believe we can talk further in this regard. Thank you very much for your briefing. Now, we are entering the second phase of the panel. We will have a discussion. Now the floor is given to Director Xing for a briefing in carbon picking and carbon neutrality. What should be the focus of our energy sector? Thank you very much. Since September, announcement of the dual carbon goals, the entire society attach great importance to this, especially carbon peaking and carbon neutrality will bring profound changes in economy and society as well. In carbon peaking and neutrality in rural areas, the central work meeting mentioned that CO2 reduction should be the key measure. And carbon emission in rural areas differ from other areas. It mainly composed of non-CO2 emissions like methane. So we study more about agriculture, including methane from rice paddies, as well as sheep and cows, and also agricultural machinery in using will burn fossil fuels, resulting in carbon emission, and also dioxide emission, but mainly it's non-CO2. According to GHG inventories in agriculture and also in domestic use of fossil fuel accounts for 7.4% of the national total. And President Xi also mentioned that we need to have measures for different sectors' emission reduction. And we are making the guidelines for the rural areas, which will be released soon. And in carbon sink and carbon reduction, we have different pathways, including reduction, replacement, sink increasing. So we need to reduce carbon emission in key areas in agricultural production, mainly including the reduction of fertilizers and restructure the feed to reduce the emission of GHG agriculture, and secondly, increase carbon sink to enhance soil carbon sequestration of farmland. For example, we can use bioactive fertilizers to reduce CO2 emission to make the land more fertile while at the same time sink more carbon. And thirdly, to use renewable energies like biomass and solar. We can use clean energy to replace the fossil fuel in production and households. And fourthly, we can reduce consumption of fossil fuels by agricultural machineries because they consume a lot of diesel. So we can phase out the old equipment and retrofit them so that they can reduce carbon emission.
To replace the CO2. Well, based on the actual work, we have proposed several key works, including the further reduction of emission of the rice field, improve efficiency of the fertilizers, boost high-efficient fertilizer applying technologies and comprehensive usage of straw, increase organic matter, reduce the pollution from the burning of the straw, and the feed management of ruminants, and healthy farming of the aqua products, energy saving of the farming facilities and devices. Well, turning straw to the farmland. Renewable energy replaced by using methane, solar energy. So for the replacement, to realize low carbon or zero carbon villages and towns. By using biomass, we can replace 450 million tons of CO2, while in rural area we have a broader potential. We're talking about rural area and agriculture, carbon and pollution reduction. In the process of production, like non-CO2 emission, we'll try our best to reduce this, but maybe zero emission is not possible. For renewable energy, we can use some technologies to effectively increase the renewable energy. This is a measure that we can control. This is a very important direction and one of our priorities. So that's my answer for this question. Thank you. Thank you, Director Xing Kexia. She talked about the future key works for the carbon and pollution reduction in the rural area in the future. Well, in the future, for the agriculture and the rural area, the carbon reduction work under the leadership of the Energy Division, together with the colleagues from the industry, together with the entrepreneurs, we'll try our best to promote the work in this field, so that we can better implement the carbon peak and neutrality targets. And now let's invite Dr. Hong Hao to talk about their experiences. Dr. Hong Hao's company, by using the rich forestry resources, they have solved the heat energy replacement for the first automobile company, and they have rich experiences. Now let's welcome Dr. Hong Hao to talk about their experiences. Well, because we need to talk about rural revitalization, so I'll talk from this perspective. Well, for low carbon life, biomass energy can play its role. Well, we also need low carbon production. Maybe the industrial park is a very good starting point. Now, the cities need to transfer their industries. The rural revitalization have this need to undertake this transfer. So, in the transient place between urban and rural area, so what resources can be used for low carbon production? And then for the manufacturing of the industrial parks, what resources do they need? So we did a calculation. For manufacturing, it accounts for 32% of the GDP, but CO2, carbon emission is much higher. So manufacturing is important emission party. So whether they use more power or more carbon. So in the 13th five-year plan, it was 46 regarding the ratio. The heat is more than power. So for the future development of manufacturing in a short period, it will keep at this level. They need more heat than power. But so the solution is more complicated. So how to provide heating? So biomass can play its role here for the transfer of manufacturing to the suburban industrial parks. They have this demand of heating. We can use biomass energy resources for low carbon development, which is very significant for rural revitalization. For example, in the end, if we can have successful revitalization, it needs some industries with comparative advantages in rural area, like agricultural products, agricultural product processing, and the waste utilization. Now, a lot of agricultural processing were not done in rural area. There are many reasons. Energy is a very important reason. That is, energy infrastructure in rural area is not enough to support the processing of agricultural products. No matter power resources or heat resources, this cannot be guaranteed. And now we are transferring the industries. So I think the suburban region is very important to use the resources in rural area. So we need to use biomass in heating. And now we are focusing on the industrial parks. With green power, gas, heat, well, by 2030, EU will start this work. Well, for the product production, it may generate carbon emission. This will be accounted. If it is not generated by green power or green gas, then they need to pay carbon tax. So with this demand, this will be a general demand in the market. So biomass is a very good opportunity. So based on our own experiences, we are providing energy solutions for industrial companies like automobile, food, pharmaceutical, chemical industry, etc. Our conclusion is when we conduct the energy transformation, if the customer were using coal, even the efficiency is the same, but through improving of the efficiency, we can reach the same cost as coal, but with the better services. Well, coming back to energy as a commodity, whether it can be accepted by the market, still we need cheap price and environment benefit. This shall not be paid by the users. It shall be mobilized by the social mechanism and a carbon transaction. So first, we need to satisfy the energy demands of the users, especially the industrial users. They have diversified demands. We need various technologies to meet their energy demands. And then, with this prerequisite, we need low cost. Recently, in Handan, we did a dual fuel system. In the past, they used natural gas. Then we add a biomass system. By using this biomass system, the user no longer use natural gas because we have a lower cost with less carbon emission. Even though not considering the carbon emission, they're willing to use biomass because it is cheaper. So in the end, what is driving the development in the industry? It depends on the market. It depends on the resources, technology, and the market demands. We need a reasonable combination. We need an industrial chain. We need a reasonable planning. So we are doing this platform design based on your resources, market, what kind of energy consumption market can you create. So we hope that we can share our experiences to all of you, hoping that we can have opportunity to cooperate with each other. So these industrial parks in the suburban area can have low carbon or zero carbon production. Thank you very much. Thank you, Dr. Hong Hao. Well, he talked about carbon tax and the 3 green energy for sustainable market application of the biomass energy. With good mechanism, that is how the biomass energy can have industrialized development. He pointed out the future direction for the biomass development. He has also shared some practices. Thank you, Dr. Hong Hao. Now let's welcome Professor Chang. We have this grand target for carbon peak and neutrality. Then facing this strategy, what is the positioning of this industry? And how can we contribute to the target? Thank you, Director Wang. Well, the renewable energy industry has a very important strategic positioning to realize the carbon target. We have the 30-60 targets. With this, we have further have a clear development of the non-fossil fuel development. The consumption percentage will reach 20% by 2020 and to 25% in 2030, and by 2060, this will reach 80%, meaning by 2060, our country's non-fossil fuel energy will be the main energy in China. So most of the energy will come from renewable energy. So regarding its strategic position, it is very important, whereas for its role to play, considering the carbon target, on the one hand, it needs to reduce emission. We think renewable energy itself is a low carbon or zero carbon energy, and then there's some biomass energy. If it can be further combined with carbon sequestration, it may be a negative emission technology. To realize the target of carbon neutrality, it will play a very important role. Well, in essence, renewable energy needs to provide energy products to the market to meet the energy demands of the market. Previous speakers have talked about very good cases. That is, how can renewable energy be combined with the rural regional energy system to be deeply integrated into the household energy system and integrated into the production, the life in the rural area, and even to the cultural development. So I think it also plays a very important role. And then our renewable energy, apart from reducing emission and providing some functions, it can also have some synergetic effect, like clean biomass energy can help to reduce the regional air pollutants emission, improving air quality in certain regions. So renewable energy, in the process of realizing our target, it plays a very integrated and comprehensive role. Thank you, Professor Chang. Well, through your introduction, now we understand that the renewable energy industry is very important for the ecological target in China. It can benefit the rural sustainable development. Well, since Director Liu Jie participated in the design of the zero carbon village design. So what is the significance of demonstration for this? So Director Liu, thank you.
Thank you very much. I believe this topic is very grand, and because, to put it simply, we can start from three fronts. Firstly, it's the seventh phase project of a global foundation to enabling the rural area in China is this topic. So, firstly, we need to achieve SDG of 2030 agenda. We have benchmarking with their goals, including clean energy, poverty alleviation, and renewable energies. So I believe this is also very significant to start to think about it. From the global perspective, in 2018, IPCC issued a report on the 1.5-degree scenario. And I believe for low carbon village, we need to think about this. Secondly, we need to align it with China's ecological conservation goals. For the dual carbon goals, it's very specific. The per GDP unit energy consumption need to be reduced by 65% compared to 2005 level before 2030. So for rural areas, we need to think about this as well in our work. And also, we need to pay attention to the pressure for the zero carbon. We account for 28% of the global share of emission, with more than 10 billion tons of emission. And our energy structure with huge reserve of coal and less oil and gas can also give us a lot of pressure. We have less than 10 years to peak. And before 2030, we need to achieve carbon neutrality. It is quite challenging. And for energy sector, it will bring a huge impact. And urbanization will be impacted too. And also in carbon emission reduction, for rural revitalization context, we're faced with more pressure. And thirdly, in rural revitalization, why zero carbon village can be a pilot? It has several advantages, including in the vast rural area, we have the most diverse source of energy. Just now, Director Xing also mentioned this. And we can largely enhance the share. And also we have more than 3 billion tons of manure from husbandry. And we have vast land as well as rooftops. All these are advantages. And secondly, in technology, for zero carbon village, it has the largest potential for carbon reduction. Zero carbon technology can be energy efficient, and they can use decentralized systems. And in terms of power, we need to further enhance the energy efficiency. In urban area, the potential is not that large, but in rural area, it has the largest potential. For example, energy efficiency retrofitting of existing buildings. And zero rural area technologies can help us reduce the largest number of emission. We have statistics behind this. For developed countries, the industry source accounts for 30%, while the residential accounts for 70%. And for us, we still have 510 million rural population. This offers huge potential for carbon reduction. And in technology, it's like this. We have 239 million mu of land and vast forests. All of them can be used for carbon sequestration. So this is also a huge potential. So in revitalization of rural area and the zero carbon village, in the future, China's rural area can produce food while at the same time can produce renewable energies. This is our vision for our project. So this is what I want to say. Thank you very much. Thank you. We hope that IDB can provide more green finance to support our pilot program. Now the floor is given to Director General Ying. Please keep it brief about the role of large and medium-sized methane in rural transition in Hunan. Within 5 minutes, please. Please keep it brief. Thank you. Hunan is a large agricultural producer So manure and the straw resources are very rich for coal using and pollution at the end of the 1960s and 70s. We have been conducting pilot program in 1918, 1990s. It's supported by the government. So the methane developed fast. According to statistics, we now have a methane pool in more than 1.72 million households. And we have 169 large methane projects and 2 large bioenergy projects. Methane played a very good role to bring economic social benefits to rural area. Take a county as an example. It's a large husbandry county. In order to turn manure into resources, it has been promoting the medium to large scale methane projects. It now has 442 such projects. And the 37 husbandry sites have been stopped or being used for other use. Methane will play a huge role in collecting waste, and it also brings economic benefits and social benefits. In terms of social benefits, it solves the manual collection and the pollution issue, and also brings clean energy to the farmers. And secondly, ecological benefits. Because it has collected all the wastes, and after anaerobic digestion, it can be used as fertilizers. This reduces pollution, and this stops the spread of diseases as well. To fully tap into the potential of methane, currently this county is using straw as well as the organic waste from urban residents as the feeders for large methane projects, and such projects have been included in the habitat rehabilitation in rural areas so that more rural residents can access clean energy in an affordable way. And thirdly, it can bring economic benefits, including, firstly, direct gas supply to the households. So it can supply more than 390 households, and it can reduce the gas cost by 1.1 million yuan. The annual production of electricity is about 800,000, and reducing the cost by 500,000 yuan. And also, the fertilizer can be used in rural areas. This county has established 30 methane fertilizer demonstration area. Every year, 220,000 tons of such fertilizers were used. And also, it can balance farming and husbandry. Thank you. Thank you. Hunan in renewable energy development. As well as the role of renewable in carbon peaking and carbon trading. It's a fine example. Thank you, Director General Ying, and the practitioners in Hunan for your years of efforts. So, This is the end of today's plenary session. Thank you very much. I would like to thank our partner ADB, as well as all the guests from home and abroad, and all of the representatives and presenters. We learned international practices in renewable energy, in policy implementation, and in carbon peaking. We learned new mechanisms and models and explored the future of energy sector in the context of the dual carbon targets, and explored how energy sector can help to revitalize the rural areas so that more farmers can be benefited in this process, and thus improving their lives. I'd like to thank you again. Thank you, all the presenters. A particular thanks to Mr. Liu from ADB, the lead climate specialist, Mr. Liu. So this is the end of today's session. Thank you very much.
太可惜了。